Hello and welcome to the first day of 1.2. Today we're going to be describing distributions with numbers. First, if we're measuring center, there are two common measures for center that are mean and median. And today we'll learn when to use one and when to use the other one. The mean, which we use an x bar for. To find the mean x bar of a set of observations, we add the values and divide by the number of observations. If n is the number of observations and the observations are x1, x2, and so on to x of n, we can write the formula x1 plus x2 and so on up to x of n divided by n, which is the number of observations. So we add up all of the things and divide by how many observations there are. Now there's a more compact way to write this, and this is what's going to be written on your note sheet. It's the sum of all x's divided by n. So this is just a shorter way of adding up all of these x values. Now x bar is what we use for the mean in this situation. So if we wanted to find the mean of these numbers, what we can do is take out a trusty calculator, or we could just add them up. Maybe I can even add these ones up. This would be 13 plus 9, which is 22, 32, 44. 44 plus 13 would be 57. 57 plus 14 would be 71. And 71 plus 15, it would be 86. So we take 86 and divide it by how many observations there are. 1, 2, 3, 4, 5, 6, 7, 8. And 86 divided by 8 would give us 10 point something. If we did it out here, 10.7. We can stop there. So 10.7 is around the mean. If we have a mean of 10 bowling scores to be 110.8, what is the new mean if the bowler bowls a 200? Well, we have 10 times 110.8, and then we add a 200 to it. So if we want to find the total number of scores, so this is 1,108 plus 200, which is 1,308. Now if we divide that by how many games he's played, because we have 10 plus 1, which is 11. Now let's see if we have 1308 divided by 11, 118.9 is the average score. All right, so if we have if we want to find the mean number of pets, what we do is there's 5 people who have 0, 7 people who have 1, 6 that have 2, 3 have 3, and so on. So what we do is we multiply the number times the frequency. So that would be 0, 7, 12, 9, 8, and 5. If we add this up, we have 13. 13 plus 12 would be 25, 34, and then that would be 51. So we have 51 total pets. Now if we want to find out how many people there are, we add up the frequency. So that would be 12, 18, 24. So to find out how many pets per family, take 51, divide it by 24, and that will give us 2.125. Hopefully I did my math right there. My arithmetic, I should say. All right, now if we are looking at the median is the midpoint of a distribution, the number such that half of the observations are smaller and the other half are larger. To find the median, we arrange all the observations from smallest to largest, and if that number of observations is odd, the median is the center observation in the list. We can find that location by taking the total number plus 1 divided by 2 and counting that much up from the bottom of the list. If the observations are even, we take the average of the two center observations. And the location of the median, again, is n plus 1 divided by 2 from the bottom of the list. So if we want to find the median of this distribution, there's 4 there, 4 there. So we take the two middle numbers and find the average. Hopefully most people can find the average without doing this. To be 11, because the number in between 10 and 12 is 11. If I want to find the median age of females, here I'll go, I can cross out the first and the last of each of the groups, and it's somewhere between 18 and 19, so 18.5. If I want to find it on an ogive, 50%, 50 percentile is where the median is. So if I go 50 percentile and then go down, it looks like about 26 would be the median in this situation. Now, mean versus median. We need to know when to use mean and when to use median. First, we need to learn the word resistance. The median is more resistant to outliers than the mean. That means it's less affected by an outlier. The mean and the median are exactly the same if the distribution is exactly symmetric. However, in a skewed distribution, the mean is closer to the long tail than the median. So if it's skewed like this, the median might be here, but the mean will be moved more towards the tail. So that would be the mean, where this blue one would be the median. Now, if it's exactly symmetric, that would represent both the mean and the median. Now we need to think about how we can measure spread. We can measure spread by looking at the differences between the largest and smallest observations. So we subtract the largest from the smallest, and that will be our range. To find percentile, we find the value such that p% of the observations fall at or below that particular value. So we add up all the observations that are at or below our observation, and then we divide it by the total number of observations in that set. So if I want to find the range for the males, the smallest value is 20, the largest value is 86. So I take 86 minus 20, which is 66. That is the range. Now if I want to find the percentile for the males, that's 36. We look at all the values that are at or less than 36. So there's 5, 6, 7, 8, 9. 9 out of, looks like there's 10, 15 observations. 9 out of 15, if I take out my calculator, 9 out of 15 will give us 0.6. So that means we're in the 60th percentile if we're at 36. Now the quartiles 1 and 3 are also used to show spread, and we can find these by arranging the data in increasing order and locate the median from the list. The first quartile is the median of all of the data to the left of the median, and Q3 is the median of the data to the right of our median. And we use Q1 and Q3 for our 5-number summary. We'll have the minimum, Q1, median, Q3, and then maximum. So to find the 5-number summary for the females below, the min is 5. The median, we said, was 18.5. And the maximum is easy, it's 33. Now we need to find Q1 and Q3. So if the median is here, we have 5 data points to the left of our median. So the one in the center is going to be 10. Now the 5 data points to the right, 29, is going to be our Q3. Now from that we can draw our box plot. It's a graph of the 5-number summary. The central box spans the quartiles 1 and 3. A line in the box represents the median, and the lines extend from the box out to the largest and smallest observations. If we drew a box plot for the females, the first thing we need to do is draw our scale. The smallest observation is 5, so we can start down here at 5, and the largest is 33. So I'm going to go up by 5 each time. And then we'll put 5 on the graph. 10 was the Q1. The median was 18.5, so that's in there. So we can draw the first half of our box. The maximum was at 29, or not the maximum, the Q3. And finally, our maximum was at 33. So this is our box plot. And on the bottom, we'll want to say what this represents, and it's female ages. All right, now if we have to estimate the mean on these two box plots, some people will think that you can't do it because this represents the median. However, we learned if it's a symmetric box plot, the mean is around there. We're not 100% certain that that's the mean, but we can estimate it to be really close to that point. However, if we have data like this that's skewed to the right, if the median's here and there's more data points out there, then the mean is going to be skewed with the data. So the mean will be further to the right than the median. In a modified box plot, the outliers in the box plot are not attached to the whiskers. So if you look at this, this point represents the 30, or that 30 means that it's an outlier. And we just don't attach things that are outliers. Now to find outliers, what we need is our IQR, or interquartile range. It's the distance between the first and the third quartiles. So we take Q3 minus Q1. And to find our outliers, we take 1.5 times that value, and we add it to our Q3 or subtract it from our Q1 to find our range of acceptable values. Anything outside that range is going to be considered an outlier. All right, so let's look at the 5-number summaries for the males and then see if there's any outliers. We know the minimum is 20. We know the maximum is 86. Those are always quick to find. There's 15 data points here, so I'll count up 7. 1, 2, 3, 4, 5, 6, 7. And this 8th one is going to be the median, which is 34. Now, since this is the median, we don't use that to look for Q1. So we have 1, 2, 3, 4, 5, 6, 7 data points. So if I count up to the 4th one, which is 27, that would be our Q1. And 1, 2, 3, 4, 50 is going to be our Q3. So we'll find our IQR by taking Q3 minus Q1. 50 minus 27 is 23. Now I'll multiply 1.5 times my IQR. I should be able to do this in my head, but 23 times 1.5 is 34.5. All right, now we use this number. We add it to our Q3 and subtract it from our Q1. Now, if we subtract it from our Q1, we'll have negative 7.5 all the way up to 50 plus 34.5, which is 84.5. These are acceptable values. Now we look at our data and see if there are any unacceptable values. It looks like 85 and 86 are both outliers. All right. And now you can get a start on the homework. Good luck.